Welcome back to another episode of our NES programming here, where we are streaming programming an NES game live on Twitch. We are working on a shooter, as we have been for, the last 4 episodes. Hopefully once we get this working pretty well, we can move on to another project. This is more of just a sort of a proof of concept and getting some stuff working and kind of learning the basics of how we're going to make a larger project, as I've mentioned in the past. So right now the game is currently in a state where that's not the folder I wanted. The game is currently in a state where not a whole lot's happening. It's you've got bullets and you've got those bad guys, and obviously the bullets don't do anything to the bad guys. We can spawn the bad guys by pressing the B button. So let's do some entity collision. If you remember last time, I had shown in this little Java application why, although this algorithm that we put together works for detecting collision, it was going to be problematic for the NES because of the limitation of the size of bytes, and rather than trying to do some sort of multi-byte collision detection, which, I mean, theoretically we could do, I'm just not sure it's really worth it at this point. There's a simpler thing we can do where let's talk about what we can do. So basically what I'm thinking about doing is we have the bullet, which is essentially just a little circle, and we have realistically, I think we really have just these 3 points that we want to check against, right? I don't think we need to check against that. You'd have to have an enemy that's coming in and kind of swooping in underneath and missing that collision point. The enemies themselves in this particular case are just squares, so we just want to check those 3 collision points and see if they're within the bounds of the enemy. Should be pretty straightforward. We're just checking if the point is between here and here, right? It's got to be in between those X coordinates, and it's also got to be between here and here, these Y coordinates. Simple enough to do in something like C. Let's see how it is to do in 6502 assembler. Alright, so we're going to do this obviously, or maybe not obviously, but obviously to me, in the game loop, when we're processing the entity. So what we want to do is, as we process the bullet, which is currently moving through the screen 2 pixels at a time on the Y, we want to essentially, after this subtraction here, so let's add a little comment here just so we can know what we're doing. Get the Y position and subtract 2. Store it and check if we carried on subtraction. You know, we could probably, I always do that. You know, that's the problem between switching between Mac and PC. You end up confusing the Windows key and the Mac key, the command key, and then you do stupid things like that. So, I mean, technically we don't have to store the Y position if the entity is going to get cleared. So if the carry is still set, we're going to go to entity complete, because that means we didn't roll over, because we didn't go down past, it wasn't, say, 0, and when you subtract, it's going to clear the carry, then making it go to jump to the clear entity. So realistically, well, If we're going to do that in the clear entity, well, we're assuming what we would do. Well, I don't even know if it's worth it. What we would do is then we would change the condition. We would check to see if carry is clear, and then if it is, jump branch to clear entity, and then if it wasn't, you would jump to entity complete and actually store the Y at that point. We can always come back to that. Do we need to store this every time? I mean, given, yeah, you know what? That's not even worth doing, because realistically, most of the time, throughout the life cycle of this entity, it's going to be storing it back because we have to use it for the next loop. It's only that one last time. I mean, I guess it adds up, especially with things like bullets, but it's just that one last time, that one last check where we don't need to do that store. I mean, I'll leave it. I don't think we would need to do that. I'm not sure. Again, over the lifetime of the game with enough bullets, probably you'd save some substantial cycles, but we'll just put it there for the sake of remembering. Only affects bullet on the last check, right? So save that. All right. So now that we've stored that and we're here, what I think we should probably do, well, let's see. So we probably want to check collision at this point, right? So the idea would be check collision with other entities if no collision, store the Y position and continue. Or rather, if we collide, destroy entities, possibly triggering explosion entity, right? We could track things like explosions or little destruction effects or something that way if we wanted to do something like that. And then otherwise continue. So let's see. Well, I feel like this would be a good place to have a subroutine. Just to not interrupt the flow of this loop. I mean, on the one hand, we could do it in here. You know, let's make it a subroutine, and then if we need to, we can always inline it if we find that the cost of the subroutine itself is too expensive. So, all right. Put it. Should we put it at the top of the other subroutine, or should we put it at the bottom? Let's put it at the bottom before the v-blank, but after the game loop. Jump subroutine, check collision. Actually, let's do this. Let's call it check bullet collision, because I want to check the special case here. All right, so check bullet collision, return subroutine. We want to push A because we are that value was the y coordinate coming into this. So where is that? So right, so A had the value of the y position in it after we did the subtraction. We need to store x because x is our current index. The y register is not being used here, so I don't think we actually care about its current value. So let's do transfer x to A and push A again. And then we're going to do a pull A, transfer A to X, right? Because the order is going to be A and then X on the stack. So we need to X and then A. And then, you know what, we do want to store the processor status because we want to be able to do that jump if carry is set, and we want to keep that. So let's pull that off. Right, I think that's what it is. It's PLP, is that right? Yep. Okay. And we don't care about Y. All right, so now we want to loop through the entities that we have. So let's load x 0. And then compare and then check bullet collision loop, compare x with what is it? It's called max. It's not max entities though, right? It's we want to do total entities times size of entity, right? Because we're gonna add that to x, and max entities is 10 total. Oh, well, total entity, wait a minute. Shouldn't that be max entities times total? This is another bug that we had from before. Let's see. Seems that way to me. It's weird that it's not manifesting as any sort of problem here. But right, that should be just total entities. And this should be compare x like that. Branch if equal to finished bullet collision. Right, and that's finished bullet collision there. Let's see if I broke something by making that change. Again, it's weird that that wouldn't have manifested as a problem. It could just be that because of the way the memory was initialized, it was just skipping over all of those spots because the memory was 0, and so it knew the entities were 0, essentially. Or the entities were no entity, so they had no meaning to the system, effectively. If I max out the entities here, let's see if I make this 3, not 93, 3. Okay, it's not doing anything. So that's what I expected to see. Now let's see if I change this back. I'm going to assume that this is going to create a weird problem because it's going to go past the actual entity's loop, or sorry, the actual entity's boundary in memory, and cause a problem. So we don't need the debugger right now. I just want to start spawning things and maxing out that so I can see where the next one is. So that's 3. Yeah, see, it's actually processing that when it shouldn't. And that's creating a problem. Okay, so yeah, that was just a bug. Glad I saw that now, because it's easier to see with fewer things going on. And I assume checking the bullet collision is working because, well, there's no reason it should, or well, not that it's working, that it's being called. There should be no reason that it's not. We can set a breakpoint and see, though. Let's hit the debugger up, and our code is going to be, let's see, where are all of those rotates? Let me go back to there. So let's see, those are the controller rotates, and then we want the code where we're doing a bunch of put, yep, here. So where did that go? It was just here a moment ago. Scrolled right by it. It's weird. Page down wasn't working. So one thing about assembly is it's easy to get lost in the instructions you're looking at because they're so short and there's very little. It's hard to see the context sometimes. That's why I like to put the no ops in to make it easier to see the code that I'm looking for. I might just do that. I think I saw the JSR. Okay, so that's the jump for the subroutine, so we're actually getting close. I don't need to put that in. Where is it? Store A, transfer A to X, exclusive OR. Did I go past it already? All right, I'm just going to put the no ops in because it's going to be easier for me to find it instead of me kind of searching blindly through. All right, debugger, and now let's look for those no ops. They're pretty visually distinct, so they should pop out. There they are. Okay, so this is the beginning of the subroutine. If I set a breakpoint here, let me remove that breakpoint and hit A for a bullet. Okay, we can see that we went into subroutine. I'm going to step over, so we're pushing A, we're pushing X, we're pushing the processor status, we're loading X with 0, we're comparing it, we're branching, and then we're pulling. Okay, and it's going to do that for every loop with the bullet. That's fine. All right, cool. So that's working as expected. Great. Just wanted to make sure that that was being called so that we didn't run into a situation where then we're like, okay, it's going to hit the enemy and the enemy doesn't disappear. You know, what happened? All right. So this is us looping through there. And now we need to check the type. So we say entities drawing a blank here, plus entity. Feels like last time we did this was a while ago. Even though it was only a few days. All right, right? Am I doing that? Yes. Okay. So there's X, and we want to compare A with entity type flyby, right? And branch if not equal to entity finished, or we'll call it check bullet and entity finished. Check bullet entity finished. And then we'll transfer X to A. We'll clear the carry, add the carry to the size of the entity. And then transfer A to X and jump to check bullet collision loop. Right? This is our finalization here where we're incrementing to the next entity so that we can then check to see if it's a flyby. So we're saying, okay, this is not a flyby, so we're going to jump. So if it is a flyby, we want to do our collision check. So again, what we're doing is we're checking to see if any of the points here, these 3 points, are within the box of the enemy. Now, certain enemies are going to have different bounding boxes, right? If you had an enemy where, that's weird, I don't know how I made it zoom, but that was cool. So you can imagine an enemy that's, you know, a complex shape. You know, maybe it has a few different turrets or something on the side, and it's got, you know, a major whatever set of guns. I don't know. I'm not an artist, obviously, so you know, we figure it's got the turrets here, and it's got lasers that come off of there, and you know, and it's firing down at you. But the bounding box of this is going to be a lot more complex, right? You're going to have a box like this, and then you're going to have a box like, you know, this, a box like that, and a box like that. No, not like that, or that, like this, and then this one, and then this one. So you'd have to check, you know, that it's within several different bounding boxes, and that's where we'd want to get into essentially a tool, building a tool that would give us the bounding boxes, or we could manually place the bounding boxes on top of the image and then have that stored off into a file that we could bring into our game. It would be no fun to have to it would be no fun to have to do that, calculate that all by hand. I see a question here from Bermiller 1421. Where you would recommend someone to learn assembly? There are a couple of really good tutorials for assembly, and specifically assembly for the NES. If you go to nintendoage.com and you go to the forum and do a search for Nerdy Nights, you find nothing. Why is that? Why is their search not working? Okay, if you go to Google and search Nintendo Age Nerdy Nights, that's a much more reliable way. Actually, that's probably the older one. There's a better one here. Yeah, so this is a good, this one was captured nicely. So you can see there's an introduction, and then it's broken down into different weeks, and it talks about sort of the basics, but there is a 6502 assembler portion here where it talks about doing writing assembly, the registers for the 6502 and some of the instructions. So that's a good starting point, and then you can post questions on the Nintendo Age forums. People are generally pretty nice and helpful, and will help you out if you have questions or you need help with the assembly language stuff that you're having trouble with. Hope that helps. So like I was saying, you'd have these bounding boxes drawn onto the enemy in pieces so that you could have a complex series of bounding boxes that you could check against. But obviously we're just getting started with this, and I want to keep it simple to start out with, so we've just got our dumb little square ship that will have just a simple bounds check. And then the other thing is, the reason I'm only checking the flyby, I mean, you could check every entity, but there's no point, right? Our bullets are not going to hurt ourselves, right? We're not going to shoot our own ship. And you could have a different type of bullet for enemies so that it would only basically check against the player, right? There's no reason it should check against enemies unless you're going to have some sort of system where the enemy bullets injures other enemies, which, I mean, you might have a reason for that in the mechanics of your shooter, but generally speaking, enemies don't injure other enemies, they only injure the player. So that's why you want to kind of break it down into these specialized cases where you're checking the entity type, because it just makes it a more efficient way of processing collisions. So all of this is to say, let's check the bullet position against the enemy position. Now, one of the things that we did in starting all of this was that we clobbered what was in the A register by loading that value into A to get the type, right? So what could we do? Probably the easiest thing and the fastest thing for sure would be to transfer A to Y. This now contains the bullet's Y coordinate. And it's fast because transferring between registers is very fast. And also, we're not going to be using Y for anything else, at least right now, it looks like. And we weren't using it in anything that was calling this, at least at this point. It might be worth putting into here something like modifies Y, right? And that's just to remind me later that Y is going to come out different than what we started, and if we need Y to stay the same, we can always push that onto the stack too. But if that's okay, there's no point in doing that push and pull unnecessarily. Now, the other thing is we could have pushed A onto the stack again and then pulled it to do the comparison of the Y value. But now that I'm thinking about it, this is actually not going to work exactly the way I wanted, because although the Y value is useful, we also need the X value. So, and when I say the X value, I mean the position. We need to know where the thing is on the screen, both the Y and the X. Please stop zooming in. Thank you. We need to know the Y and the X to do the collision check. And that we don't do anything with the X value at all in this code because the bullet only moves vertically. So realistically, what we probably want to do is we probably want to use the Y value to find the actual entity in memory. I scrolled past that subroutine because I was talking at the same time. All right, so what we actually want to do, I think, is we want to transfer a, let's see, we want to transfer x to a, wait, so we've pushed a, we transferred x to a, we've pushed x, we've pushed the processor state, so x is already in a, so transfer a to y, so now this contains the index of the entity from the preceding call, right? So let's do this. In x contains entity of index of current entity out nothing, none modifies y, and let's put that. Whoa, what? That was, well, okay, Windows, seriously, just work with me here. Okay, check bullet collision. Just put this comment here to kind of separate it visually in the code from other stuff so that we know that it's a subroutine that we're implementing here. All right, great. All right, so we have y, which we haven't modified, which has the current position or the current index of the entity that we are that we are processing when we wanted to check the collision with this flyby. All right, so what we can start off with is the x position, and so what we would want to do, so we want to load a thinking about this. Want to load, I guess it doesn't really matter which, yeah, it doesn't really matter. Okay, so we're going to load A with entities plus entity x position x. So get the leftmost position and compare it with the current bullet position. And we're going to have to do this for the 3 different collision points, right? Because we said we want to check to see if it collides here in this spot, here in this spot. We'll do it in red. This spot, and this spot. Okay. So this spot looks like approximately, and again, with more complex things, you'd probably want to use a tool to check this out. So to determine this, so we're looking at if the position is the top left corner, we're looking at 1 pixel over and 4 pixels down to start off, right? So all right. So we want to load the X position of the flyby, and then we want to subtract from it the position of the X of the bullet. Let's go to the 6502 reference that I use because I want to see what we have at our disposal here, because I don't remember all the instructions. So subtract carry can subtract from the 0 page, or okay. We can subtract memory address, okay, which is what we want. So what we would want to do is we want to set the carry. We want to, well, so we're going to need some temporary variables here. So let's add a couple. We want to be able to have a variable that has the X position and the Y position that we're checking against, and those are being checked separately. So we don't need to have two separate variables. What we can have is we can have a collision temp, we'll call it. Used in the collision routine to store the X or Y value we're comparing against. Right, because you are not able to do, you're limited in terms of what you're actually able to do these operations on, right? So the subtract is always subtracting from the accumulator, the A register, which means that in order to do these checks, we're going to have to first take the bullet position and then calculate the X that we want to check against, store it into that temp variable, then load the X position we're comparing it against, and then doing the subtraction and seeing if it's within, if it's greater than that X position of the flyby. So again, to kind of rephrase that, well, let's do it, and then maybe that'll be enough. I'll see as I do it. So, all right, so we load, and then we want to say, okay, X position Y, right? So Y has the index of the thing that we were, of the bullet that we were looking at for this collision. So get the bullet's current X position. Let me just make sure that I'm not messing this up by using the Y here. No, because that's not an indirect. Okay, so that's fine, right? And then we said for that particular entity, for the bullet, we want to check the point that's on the left-hand side, which is just 1 pixel greater than the leftmost pixel, right? So we can then Windows and their stupid shortcuts. So the increment, we'll do memory addresses. It doesn't increment the, okay. And I don't want to do, yeah, so I just have to do, all right, so I just have to do, there is no increment on the accumulator. You just do clear carry, I'd carry 1, right? Get the bullets collision X collision position. And again, this is something that, you know, we wouldn't necessarily be calculating on the fly as we progressed, right? This would be something that we would hopefully, as we progressed and made the game more complicated, build a tool for drawing the bounding boxes and placing the collision points rather than doing this. But because this is simple and we're just getting started, we're going to do it this way. And TraceX dump, hey, how's it going? So, all right, so clear the carry, add the carry, so that's the X position. Now we're going to store A into what did I call that? It was something like collision temp. Okay, collision temp. Okay, so we're storing that into collision temp. We are loading the position of the flyby, and then we are subtracting carry collision temp, right? So now we're saying, so we can call this XB for bullet X, and this is XF for flyby. Forgot the brackets, this is just going to be confusing. So we're doing XF minus XB, right? And now, so now basically if the bullet point is greater than this leftmost point of the entity, we're going to get a negative number because the X position is going to be bigger, right? So if it's bigger, then we're going to get a minus, which means that if we get positive, we know that this collision point doesn't fall within the bounding box. It doesn't mean it's necessarily within the bounding box because, for example, it could be positive. It could be greater than this X position, but also way over here, which means that it's not within the bounding box. But we know that if it's over here, it's definitely not going to be within the bounding box. That doesn't mean one of the other points may not be. So if it's a positive number, we're going to go to check collision point 2. Now the thing with this approach is, as you'll see, it gets kind of verbose because we're spelling out each collision point in code versus doing it in data. But I want to do it this way first just to make sure it works, and then what we can do is we can backtrack on this and make this be driven by could we do that? We could have an array of offsets, one for X and Y. Yeah, so we could, so the collision points could be stored in data that are offsets, saying, you know, it's offset by, it's the current position offset by a certain amount, and then you use that to check against the bounding box of the entity, and you just loop through that instead of doing what we're doing here. But again, I'm doing this because I want to do this longhand just to make sure that this works, and then we'll circle back. So part of it because I'm still getting back into writing assembly and thinking about things at this level versus just writing it in C code or C# code. If it were C or C# code, it would be kind of a no-brainer because you're doing super simple comparisons and saying, is this greater than that? Is that greater than that? Really simple. We could use that algorithm that we did last week where it's really, really basic. All right, so anyway, so if the X of the flyby minus the X of the bullet is positive, then we're going to check collision point 2 because we know collision point 1 is to the left of the flyby, right? Because if it were negative, then it would, and again, see, and then this is the other problem. If the difference is big enough, will it trigger a false positive or negative, or false plus or minus? Potentially. I'm thinking it's possible. I'm not sure how we would handle that. Well, let's go through with this, and then we can revisit that, where basically we'd end up in a situation where, again, it's similar to the algorithm that we looked at last week, where the difference between the two entities being checked are so great that because the bytes are signed, we wouldn't be able to accurately represent them in that range that we have available, because we have the minus 127 to 128 to positive, well, to positive 128, right? And if we get beyond that, we might have to do the double byte check that I was trying to avoid, now that I'm thinking about this. But again, it doesn't hurt to go through this, and then we can see why that was a bad idea to do this. It's all part of the whole learning process, right? So check collision point 2 will be here. So if it was negative, then we know that the position of the bullet is actually greater than the position of the flyby X. So now we need to check to see if the position of the bullet's collision point is within the right-hand side over here, right? Because right now we're checking, all we're doing right now is we're just checking this. We're checking, is the bullet collision point within that range of X values. So, all right, so now the bullet collision point is still loaded into collision temp, so that's good. What we want to do is we want to load the X position again, right? And then we want to clear the carry and add the carry, add with carry 8, because the flyby is a full 8 by 8, so we want to check to see if we're within that range. So again, now let's set the carry and subtract collision temp. And if the, all right, so what we're doing here is we're saying get the flyby X, using the same notation, get the XF, and XF plus equals 8, right? And then we're saying XF minus XB. So now, in this case, we're saying, okay, if XF minus XB is positive, then it's within that X range, right? Because the bullet collision point has to be less than this line in order for it to be within the bounding box of that flyby. If the value we get is negative, we know that the collision point is actually greater than the X value of this line down here. So branch minus check collision point 2. Okay. So now, okay. So at this point, let's establish what we know. We know the X position of collision point 1 is within the bounds of the flyby, right? And I can see already where this is like getting tedious to have to do this for every collision point, because now we're going to have to replicate this code for every single collision point that we have within the bullet. And it's like, you know, why would we do that versus just having a data structure that represents the bullet's collision points and just iterate through that, where the difference in value is literally what we store into collision temp. And we do one check for X, and then we do one for check for Y, and if that fails, then we loop back. And you know, let's do this for collision point 1, which is that left-hand side one, and let's see if we can test that it's going to kill the entity. And then let's go back and rewrite this to use an array of these offsets for the collision points, because yeah, I don't know about you, but I don't want to have to rewrite this 3 times for the 3 points, and I also don't want to copy paste that code. It's kind of kind of not the best way to do this. So let's do this. Let's load the entities, Y position, get the bullets, current Y position, clear the carry, add the carry. So we want to go about halfway down, which would be 4, right? So we're adding 4, and then we're storing it in collision temp. So that's our new temporary that we're checking against. So now let's get the Y position of the entity itself, set the carry, subtract collision temp. And so now what we want to see is first is the position of the collision point, is it greater than the top left, the topmost corner, the topmost point, right? So now, whereas before we were checking, is it within the range of possible X values that would fall within the box? Now we're checking, is it within the range of possible Y values? Is it gonna fall in here, right? So we've got to subtract the collision temp. We'll put the same kind of comments as we did before, just to make it clear. So here's flyby Y. Oh, Y flyby plus equals 4. Oh, no, sorry. That's the bullets position. Increment by 4. Storing collision temp. Right, get the entity topmost point position. We'll call it YF. Oh man, what did it do? All right. Let's just setting the carry. So this is YF minus YB, right? So if the bullet is within the range, the YB is going to be greater, which means that we're going to branch if it is positive, which means that the YF is larger than YB, to check collision point 2. Let's put into this comment here what we're actually looking for. So XF is greater, let me see, so we're subtracting XF from XB. XB is greater than XF, because if it is, then no. So we're saying XF is greater than XB, and then here again we're saying XF. Now we're saying XB is greater than XF, right? Because if it were greater, then it would be minus. And then so if it's positive, then YF is greater than YB. All right, so that's that. And then the Y position stays the same for the collision temp. We need to load entities Y position X, get the entity topmost position YF, and then we're going to clear the carry, and we're going to add 8, right? Because 8 is the topmost, or sorry, the bottommost, right? Because the screen goes from 0 to, 243 or whatever the highest Y value is. I think it's like 243 or something. Doesn't matter. The point is Y increments down, right? So the towards the bottom, it gets bigger. So it's the bottommost that we're checking. So get the bottommost Y position at YF via YF plus equals 8. It's not consistent with how I was doing it before. So let's say YF plus equals 8 bottommost, right? Just to make it clear what we're doing. And then again, we're going to set the carry. We're going to subtract from A the collision temp. I'm going to say YF minus YB. And if it's positive, that means that YF is greater than YB, which means that it's not going to be sorry, I got a text message that distracted me just now. If the YF is bigger than YB, then we're going to get a positive value, which means that it's within the bounds. If it's minus, then it's outside of it because YB is bigger, which means we want to skip destroying the entity, the flyby. So branch of minus to check collision point 2, right? So YB greater than YF. All right, so at this point, we know the X and the Y, not the 7, the Y, are both within the bounds of the flyby box. Right? Great. So it took all those instructions to figure that out, but now what we can do is we can basically destroy the entity, because now we know the bullet has hit it. At least that one collision point of the bullet has hit it. So what we want to do is we want to load what we could do is we could do some sort of cool animation that, you know, the enemy ship explodes and stuff like that. But for right now, let's do this. Let's load A with entity type no entity, and then store A into entities plus entity type Y, right? Destroy the flyby entity by changing its type to no entity. And then jump check. That's definitely finished. To finish bullet collision, right? Because we're done. We don't have to check anything else. We know that bullet collided with that enemy. We don't want to be checking against any other enemies because it's not something that's supposed to... you can envision a case where maybe you want the bullet to continue to... If it was like a special weapon that the bullets can hit multiple enemies, it would continue to check through the entire list as it traversed the screen, and then it would destroy the enemy each time it found another enemy that it collided with. I guess you'd probably want to do that for every enemy and cycle through all the entities in case you had two enemies that were overlapping. If you allowed that, I mean, you could short circuit the check and say, okay, I've destroyed one enemy, I don't need to check the other ones until the next loop, just because if you didn't allow overlapping, it wouldn't be possible for the bullet to hit two in one cycle. But who knows? It depends on how you want to make your game, right? So this would be for collision point 2, and like I said, this is a lot of code to be copying and pasting for 3 collision points. It seems smarter to make this a loop where we iterate through some data in the cartridge for the bullet collision points rather than writing out each one by hand. All right, so let's see how badly I messed this up. 49. Oh, yeah. Okay. 540. Finished bullet collision. You know, I would have felt bad or concerned, I should say, concerned if there hadn't been some sort of errors when when assembling this, because then you get nervous, right? You get nervous that something else is wrong. All right, so that's just kind of stupid superstition, but it's like usually when you've made these many code changes, it doesn't compile, it doesn't assemble, unless it's like super simple. All right. Well, the good news is that's still working. If we fire a bullet, no, that's an enemy. Well, okay, so that was cool. So the bullet didn't destroy the enemy unnecessarily when we didn't shoot it. So if we create an enemy and fire a bullet, okay, it destroys the bullet, but not the enemy, right? Because I changed the I changed the bullet to be no entity, but I didn't change the flyby to be no entity. Hold on. All right. Oops. Right? You gotta do both of that. Both of those things. Destroy the bullet. Destroy. I wasn't expecting that. Destroy the entity. I actually wasn't expecting it to work at all, so that was kind of cool that it destroyed the bullet and not the enemy. All right. It's still doing the same thing. What am I messing up? Oh, dummy. Yeah, put it after the jump. That's a great idea. Awesome. Okay, so we've got our enemies now there, and as long as we hit it with that one spot, you can see that when it collides just so, it destroys them. All right, so I see people in chat. Let me take a quick look here. So Unrussell Jimmy's, do you work at a Big Four? No, I am a professional programmer, but I do not work at a Big Four. I've been working professionally as a programmer for the last 20 years. I've actually been working professionally as a programmer since I was 16. Good question, but no, game programming is just something I've always been interested in, and I started this stream because I was really interested in NES programming, and I thought it would be really cool to do a live stream to kind of show people what's involved in making a game for the NES, so that people can see, that it's still a pretty complicated thing. Now, it's not like a PC game or an Xbox One game or something like that, where there's a lot more complexity in terms of the math involved in doing something like 3D graphics and whatnot. If you're interested in seeing how games are made on the scale of like a PC game that's using 3D graphics and stuff like that, you should definitely check out Handmade Hero. That's a similar concept to this. It's live streaming game programming. Casey Muratori has been doing it for, well over a year now. I want to say 400 some odd episodes of doing programming on a game, no engine, no libraries, just all from scratch. He started off even just using drawing routines directly in Windows using the GDI routines and writing, handwriting blending, and drawing routines using optimized Intel x86 intrinsics, which are basically the way you access assembler instructions in C and C++ on Windows, so that you can do things like complex operations using the instructions on the x86 that do vector multiplication and stuff like that. It's really an awesome stream, and if you're interested in seeing what that looks like, you should definitely check out his stream. He streams on Twitch, and he has all his recordings on YouTube also. It's a pretty excellent stream. So thanks for the question. All right, so this is kind of great because we've got our enemies that we can spawn, and I can destroy them with my bullets. You know, nothing fancy. Like I said, what we could do is, if we wanted to, we could, in this portion here, instead of just setting it to no entity, we could create a new explosion entity, right? Where basically within one of these slots here, we're now creating something that would just animate an explosion for the bad guys. That would be kind of cool. Unfortunately, I don't have an explosion artwork right now, so we're just going to leave it at it will despawn the bullet and the entity. I'm pretty happy that that's working in one session without any major issues. So that's pretty cool. So let's go back to what I was saying about these different points and the fact that I don't really want to write this code by hand. So what we did is, like I said, we checked these we checked this first point here, right, with whether or not it's within this range of X and Y. And, you know, and that worked insofar as it was, but now we've got to do it 2 more times. You know, you could imagine a scenario where not only do you have to do that for each of these points, but there are 10 points or 20 points or, you know, however many. I mean, probably not that many on the NES because the CPU can't handle that much. But, you know, from an arbitrary perspective, you could see how that would be a lot of code to write for each of the different entity types. And then on top of it, you know, we talked about this idea of the enemies having multiple bounding boxes. So now you'd have to write this sort of complex set of checks that are specific to each bounding box. We don't really want to do that. I don't want to do that. With the case of this enemy, it's pretty straightforward because it's just a single bounding box. But really, that's a generalized case of a single bounding box where we could do n number of bounding boxes, right? It could be 1 to 1,000 or however many we could squeeze in the number of cycles we have, where we then check to make sure that we are getting whether or not we're getting collision with the collision points on the bullets. So right now I'm not on any. I mean, I'm on the Discord server for Nintendo Age, similar to a bunch of other people who are doing NES programming. Give me 1 second. I've got somebody who is belligerently calling and texting me. I will ignore him for a moment. So Casey's channel, I'll get that right there, is... There it is. So the one I was referring to is this. That's Handmade Hero. And he, like I said, he streams. Right now, I think he's only streaming on weekends. He used to be streaming every day for quite a bit, and I think he had to scale it back. He's working on a pretty large scale project, and he does, I think, consulting work as well for games companies. So he's a pretty busy guy. But when he does stream, he streams on the weekends, and he streams for a couple hours at a time. So you should definitely check that out. And like I said, I'm on the Discord chat along with a bunch of other people who have been doing NES programming for a lot longer than I have, including Kevin, who's under Khen Games on the chat here. he has been doing this for a long time. He's put out some really excellent games, and he actually does a podcast. I mentioned on the last episode he does a podcast about NES programming. It's called The Assembly Line. Definitely should check that out as well. So let's start the arbitrary collision point checking. I'm not going to be able to finish it tonight because I'm going to have to end the stream for the evening. But let's talk about what that looks like, and then we can talk about what we're going to do, and we'll wrap it up, and we'll do it in the next stream. So what I really want to do is I want to have something like bullet collision X and bullet collision Y. And for these two areas, and this is the same thing as what we're doing with the palette, where it's just defining bytes that represent the color values that we want to store in memory at some point. What we're going to do here is we're going to store the offsets of the current bullet position to determine what our collision points are that we're actually checking, and we're going to do that in a loop, right? So the first thing we checked was we were checking that X was 0 and Y, or well, X was 1, right? Because if we go back to YYCHR, it's offset by 1 pixel, and then it's incremented by 4, right? So so the X is incremented by 1, and the Y is 4. And then our next collision point is on the top, which the X position is 4 and the Y position is 1, right? We're just adding 1 to that position. So we're just essentially doing kind of a swap here. And then the final one is the X position is 7 and the Y position is 4. Right? So, you know, pretty simple stuff here. Probably want to do something like bullet collision point count 3. And what I'm thinking, so what I'm thinking is, you know, earlier I had mentioned you'd have a scenario where you'd have a tool that would allow you to define these points. I mean, that's what it would output, right? It would output here in a format to your file or to a file you include this kind of information, right? Because this is just raw data. This is and it's literally 6-7 bytes. It's not that much information, and you'd want a little bit more organization around it because you don't want to have it just kind of be, you know, a bunch of files. You would probably want to have it be organized a little bit better, but that's essentially the way that this goes. So now what we need to do, and this is where it gets a little more complicated because we're using Y and X to index into the memory of the entities, but we also need to get the offsets that we're adding from memory, and we would do that normally by indexing. So we're kind of out of indexes, but that doesn't mean we can't do it. It just means that we've got to figure out a different way. So let me double check before we do anything. Can I do add with carry? So you can do an add with carry from an address, but the problem with that is that the address is an absolute address, which means that it would be fixed. So what we can do is we can do what we're doing with the sprite mem, right? Where we're loading the address into sprite mem and then sprite mem +1, and then we're using it later. And that should work. And then, you know, we do an increment of, we can do an increment of, we don't do it here because we use sprite mem using the indirect indexing with Y, but because we have Y in use, I mean, there are a couple of things we could do. We could do an increment of the address so that we can index through using the absolute memory position to add the value as we need to. The other thing we could do is we could use the stack and push the indexes onto the stack as we need them for other things. So we can push the Y or the X index onto the stack do the work that we're going to do to get what we're going to get the value we need to add to the X and Y position, and then pop it off when we're done, so that we're back to the Y or X value that we had when we started. It's just kind of shuffling it around, right? It's this point. At this point, that's why. So one of the big things when you look at assembly and you look at how fast processors can run, one of the big things that you need to consider is the number of registers available. So the reason for that is because registers are basically, like, you can consider them free. I mean, they're not free, but they're really fast to read and write to. Where you start getting into slowdown is when you're accessing memory, right? Because memory is a lot slower by comparison to registers. And then on a system like the NES, I would imagine that storing into a cartridge is pretty slow, even compared to memory. On a PC, even with a solid state drive, people talk about orders of magnitude of slowness. A drive is several orders of magnitude slower than memory, which is several orders of magnitude slower than registers on the processor. So you want as many registers as possible to help try and optimize the things that you're operating on. I mean, eventually you have to go to memory, right? There's no way around that. And so because of that, you have to pay that penalty. But if you can load everything you need into registers, then you don't have to worry about paying that penalty more than you need, or more often than with fewer registers, because you don't have to play this juggling game of, I need this thing, but then I also need this other thing, and then you're kind of like shuffling them around as you need them. And that's kind of the interesting thing about writing in assembly, right? Is that when you write in higher level languages like C, C++, C#, all of that stuff gets hidden away. All that stuff is actually abstracted away from you, and the compiler tries to figure out what the best way to do it is. And that's kind of the cool thing about writing an assembly, is that you get to see that detail, right? You get to see exactly how these things get shifted around and understand why. And then that's where a human is better at optimizing in some cases, because knowing the entire flow of your code versus a compiler that's doing certain local optimizations, you can do little tricks that use the registers more often than the compiler would, or access memory in certain ways that it's faster because you're organizing the things that you use more frequently into 0-page memory instead of into other locations in memory. So there are all these tricks that you can do as a programmer writing by hand that people used to do in in the 80s. Well, further back than that, but when I was growing up, when people were writing games, that's in the 80s and the 90s, that was still a thing. People still do it now, but it's you have to be talking about somewhere where they're writing games that every frame counts, and certainly with some of the games we've seen these days, that doesn't come into consideration. And forget about it when you talk about business software. People don't care as long as software gets out there as quickly as possible. I mean, if you've used any of the creative packages, which I will not name at the moment, but I'm sure you can think of which big one I'm talking about, every subsequent version of it gets worse and worse, and slower and slower, and it's because performance has kind of been left by the wayside, because everybody's like, oh, the compiler will handle it for me, the garbage collector will handle it for me, except that it doesn't, because you still have to know what it's doing. And so that's where something like learning assembly and how the systems actually work, and knowing how your CPU actually works and your computer actually works, is really important to writing good software. So I'll get off my soapbox now and ask if anybody has any questions before I wrap it up. We'll do it again Thursday, 9 Eastern. Was glad to see people asking questions this time. All right. Well, I don't see any questions. I'm going to stop the recording. I'm going to put this up on YouTube like I've done with all the other episodes, and I'll put it here on the Twitch channel so people can go back to the beginning if they want to. And you can find me, as I've said, in the Nintendo Age Discord. I'm at Clairvis on Twitter. And yeah, I'll see you guys Thursday. Thanks for watching.